make sure that everybody is comfortable graphing. So let's do this. These are the P3 notes. Let's do the last problem, number 5, 5B. If you have been playing speaking of calculators, let me share something that I just learned this morning. Okay, I don't know whose this is. Somebody brought this in and put it in the charger because the screen was black. Okay, we thought we needed charging. And then it left it in there for I don't know how long it was in there, but took it out and it still doesn't work. Found out this morning that little battery back here only lasts 2 years. So if your calculator is 2 years old or more, you probably better have a backup battery on hand. Okay, so there's a little, you know how your watch has a little battery in it? Or, I don't know, there's little watch batteries, they're called, there's a little round things. It goes in here. So you need to replace that. If you can't get your calculator to charge, then probably, there's nothing wrong with the calculator, you just need to replace that battery. Okay?
Do you have an extra notes? I think I left mine at home.
Well, that's bad news. You'll have to go back to the thing that says honors to see if there is one. Otherwise, you'll just have to do it. It's in Canvas. If you want to pull it up, put it in your ability. You can do that too. All right. So now we're going to graph this problem. So I'm going to go through it, even though we really don't have a lot of extra time. This is important. So I'm going to go through it with you both ways. The way the problem is set up, it's set up to do with intersections because I have two different things that I want to compare. So I was doing other problems on my calculator. So the first thing I'm going to do is hit zoom 6. And what that does is give me what we call the square screen. I mean, it's standard screen, not square, standard screen. -10 to 10, -10 to 10. You can certainly go to Window and input those manually, but a real quick way to get your standard screen is to zoom 6. Okay, go to y equals, I don't know if you have anything in there, but clear it out. And then put in x squared, and do we remember how to do that? Our x variable button right here where I'm pointing, and then squared. And then for y sub 2, put in 5x plus 1. So this is y sub 1, this is y sub 2. And then hit graph. And you should see, oh, wait a second. Do you see something that looks like this? Now, if I have set my problem up like this, I am looking for where we intersect. And I have a feeling that intersects, but I can't see it. So I'm going to go back to my window. And what do you think I need to change if I need to see more of my graph up here? Y max. And I'm going to go ahead and make Y max 20. Still wasn't enough, was it? So I'm going to go ahead and make Y max 40. Oh, now I can see it. Can you see it? If you make Y max 40, you should be able to see that other point of intersection. Now, was there anything sacred about 40? Could I have used 50? Yeah, I was guessing until I see what I want. All right, everybody got the picture? Okay, so now everybody's paying attention, so we don't have to repeat. If you know what you're doing, go ahead. If you don't, you need to listen. So now I'm going to second calc. Calc is in the second trace. It's the calc menu, second place. I'm gonna go down and pick intersection, because that's what I'm looking for. I'm looking for where the two pieces of this problem intersect each other, okay? Now, as soon as I do that, as soon as I press intersect, I get a cursor, move.
Pardon this interruption. At this time, all Irish Adrenaline wire members should report to the WAC format. Thank you.
This is the point I'm looking for. So move that cursor using your left arrow button. Move that cursor so it's over here somewhere. Anywhere over here, doesn't matter. And press enter. Now move it the other direction till it's over here somewhere. The cursor will automatically set the left bound on the first curve you put in, and it will automatically set the right bound on the second curve you put in, which is the line. So set it over here somewhere. Press enter. Now, those of you with new calculators, you should physically see a line here and a line over here somewhere. I see these little arrow things like this, that's how I know. Move the cursor in between those two lines, or in between those two marks, and press enter, and it will tell you that the coordinates of this point right here are negative 0.193, comma, 0.037.
So I got.
Perfect. Now I'm going to do exactly the same thing for this point. So I have to go back to the beginning. Second calc intersect. Now where do I want my cursor? I want my cursor over here somewhere. I need to surround this point. So I'm gonna move it over here. So left arrow over, it's there somewhere. All right. Now on my line, I need to be up here somewhere. So move it now on the line. And move it down somewhere between there. And that one is 5.193, 26.963. How does that point look?
So I got it.
I'm loving it. Okay. Technically, these dots should be closed in. No one's grading your picture, but they are included because of that, right? And my answer is going to be, I got a lot of extra junk in here. My answer is going to be where the parabola is higher than the line, right? This thing was a parabola, this thing was a line, and I want the parabola to be above. So where does that happen? The parabola is above the line here, and it's above the line here. Your answer is your x intervals. So negative infinity to negative 0.193. Oops. Or 5.193 to infinity. Because when you graphed, you needed your first curve to be above your second. And that's where it happens. Remember, we're looking at x values, boys and girls. The equation is x. Okay? Now, we're going to do it the other way. It makes no difference. You'll do whatever you like to do. But I want to go through this to make sure we're all on board. If you don't want to mess around with two separate curves, if you'd rather just have one picture to deal with, then you got to move everything over on one side. You okay with that? All right, so now we're going to go to y equals. Clear out the old and just type in this one equation right here. We'll just type that in right there. So x squared minus 5x minus 1, and hit graph. Now my window is still set from the last problem. It doesn't matter. You can reset it if you wish, but I get something that looks like this. Is that what you got? No one's grading your picture, just that's what we should have. Now, we don't have anything to intercept. We are looking for where the parabola is bigger than 0 or equal to. So would you say that's this part of the picture and this part of the picture? So in order to answer the question, I need to know where these 2 points are. They are x-intercepts, otherwise known as zeros. So when I go to second calc, this time I choose 0, and then I do exactly what I just did. Set the cursor over here, set the cursor over here, set it in between, and hit enter. So cursor over there somewhere, cursor over there somewhere. In the middle, that one is, oh my goodness, negative 0.193. And then second calc 0, I'm going to find the other one. So I set my cursor over here somewhere. Set it up here somewhere. Set it in the middle. And that one is 5.193. So do you see what your answer is? It's everything from negative infinity. Again, we're looking at x's now. X's. So negative infinity to negative 0.193 and then 5.193. All right, those are the 2 ways that you can graphically solve an inequality. Good? All right. Solve for the indicated variable. That means whatever they tell you to solve for, get that letter by itself. What is 6a, the formula for? Anybody recognize that formula?
Trapezoid.
Area of a trapezoid. Yep, that's the area of a trapezoid. And we want to solve for h. So right now, it's solved for a. A equals, a's by itself. We want to get h by itself. So what do you think?
Multiply by 2.
Okay, that's gonna have to go over, and so is that. So I'm gonna multiply by 2 first and just get rid of that. And then I'm going to divide. You can do it in either order. This is, I'm the one standing up here, that's the order I like, so that's what I did. But as long as you end up with this, it's all good. Okay? Next one. What's this the formula for?
Sphere.
Sphere. Volume of a sphere. And we are solving for R. So what do you want to do? Okay, so multiply by 3 and divide by 4, or multiply by 3/4 if you want to do it all at one time, right? Multiply by 3, divide by 4. Now what? Yep,
Divide by pi.
divide by pi. But don't let me see this kind of stuff, okay? Because that's called a complex fraction, and we don't want those. So think about what you're doing. Don't make it hard. You are dividing by pi or multiplying by 1 over pi. So you have 3b over 4 pi. No complex fractions. Then you okay? Avery? Now you keep her, yep. So R equals the cube root of 3b over 4 pi. And by the way, that 3 right there is necessary, so be sure that you're not leaving that out. If it's a cube root, you gotta have that in there. A-okay? All right, so this homework's due on Monday. P3 will be due on Monday. All right, P4, slope of a line, m equals, who remembers how we calculate slope?
X2 minus X1 over Y2 minus Y1.
If I'm zooming, am I getting a thumbs up for that? Slope is rise over run. Rise over run. Which variable is this?
Y2 over Y1 minus
Y over X. Delta Y over delta
You know what I
X.
mean.
Now I got a thumbs up. That is slope. Rise over run. Y over X. Sometimes we see that delta Y over delta X. Change in Y over change in X. What is the point slope form of a line? Now Y equals mx plus b is not point slope. That one is slope intercept. So you can put that down for slope intercept. M is the slope and b is the y-intercept. And what do we mean by y-intercept?
Where the line touches the y-axis.
Where the x value is equal, where we cross the y-axis, right? Okay, back to point slope. What's point slope?
Y minus Y over 1.
There we go. Y minus y sub 1 equals m x minus x sub 1. Point slope is the slope formula with this moved over. You see that? That's point slope. Standard form of a line. They know what that looks like?
That's all variables on the same side.
That's where you have ax plus by equals c. Yep, that's called the standard form of the line. What do you know about a vertical line? What does that look like, a vertical line?
Perfectly straight up and
Yeah, so graphically, yeah, what about its equation?
the x stays the same the entire time.
So the equation would be x equals, well, it could be 0, it could be any constant.
What?
So x equals 4, x equals 5, x equals 6. Those are all vertical lines. How about horizontal lines? I'll just say B because that's what we use over here, but yeah. Now, if the line is horizontal, its slope is 0. Doesn't that make sense if it's horizontal, rise over run? But what if it's vertical? It's undefined, so the slope is undefined, or there is no slope. Because look at the slope formula. Cole said the x's are the same. Well, if these two numbers are the same, then I'm going to have a 0 in the denominator, which means I'm not. Okay. X-intercepts, we talked about that a minute ago. If you have a line, these are called the intercepts. Whatever the y-intercept is, it's 0 comma something, right? And whatever the x-intercept is, it's something comma 0. They're points. Parallel lines, what do we know about parallel lines? What do we know about the slope of parallel lines? They're the same. Think about it. They're the same. What do we know about perpendicular lines? Their slope is? Their arc. What?
It's the opposite.
Opposite, reciprocal. Yeah, so it's like combining the additive and multiplicative inverse. You change the sign and flip it over for perpendicular lines. Okay, so we should be able to roll through this. Find the slope of AB. Go ahead, do A and B there by yourselves. Compare notes with your friend. I'll do it quickly. We'll see if we get the same answer. finding slope. Trying not to make any mistakes. I got 3 halves and none. Now, remember, if there's none, the line has to be vertical. Think about these 2 points. 5, 2, and 5, negative 1. Don't they make a vertical line? So it makes sense that there would be no slope. You okay with 3 halves up here? Cool?
Wait, so would undefined work for me?
Uh-huh, yep,
Okay.
yep, undefined. No slope, all that means the same.
But that's not the same as 0, right?
No,
Okay.
no. 0 would mean my points were in a line like this. Yeah. Okay, one myth I want to dispel. When you do slope, I know when I wrote the formula here, I did y2 minus y1 over x2 minus x1. It doesn't have to be in that order. The rule is, you can subtract in any order you want here. You can do negative 2 minus 4. But if you do negative 2 minus 4, then you gotta do negative 1 minus 3. So the order doesn't matter, but you gotta do the same order both times when you do slope, okay? All right, if the slope of AD is negative 7/5, so this is A and that's B, find X. All right, so my slope is negative 7/5, and my points are these. Any ideas there?
Point slope form?
Just plug in the variables.
I think we can do the point slope form, but I'm kind of thinking, because it's essentially the slope formula, I was thinking of 4 minus 3 over x minus 6 would have to equal negative 7/5. Does that make sense? Y minus y over x minus x has to be negative 7/5. Isn't this how I find slope? And they tell me what the slope is, so I'm just set them equal. So 1 over x minus 6 equals negative 7/5. How do I solve that?
Cross multiply?
Cross multiply, that's what I would do, cross multiply. So 5 equals negative 7x plus 42. Did you get 37/7? Easy enough. Write the point slope form of the line through these 2 points. Point slope form of the line. Okay. What do you think? Point slope form, remember, is this one. What do I have to know? I gotta know slope. So whatever else you're thinking about doing, you gotta have the slope. You cannot write the equation of a line without the slope. So I'm going to find the slope. So 7 minus 1 over negative 2 minus 6. Double check my arithmetic. Is that good?
Yep.
Okay. Now, pick a point. Doesn't matter which which one. Your answer will look different, but it will be the same set of points. So don't worry about it, just pick one. Which one do you want to use, first one or second one?
Either second one.
Second one? I like that one too, those numbers just look nicer. So y minus 1, this becomes your x1, y1. Whatever point you pick becomes your x1, y1. So y minus 1 equals negative 3/4 x minus 6. And this is the beauty of point slope. You are done. That is the point slope form of the line. Finished. Finished. Write the standard form of the line. So our answer, that's going to be our final answer. That's the way I want my answer to look. My points are 6, 2, and 7, negative 3. I'm going to, oh, Alex? Absolutely. You can't write the equation of line without the slope, so we're going to find the slope. So what is my slope? 2 minus negative 3 over 6 minus 7. I got negative 5. Is that right?
Yeah.
Now, I'm a point sloper. I love point slope, so I'm going to point slope. Y minus 2 equals negative 5 x minus 6. Well, this is my the point I chose. So I did y minus 2 equals negative 5 x minus 6. Do you see where I'm going with this? I'm going to distribute. And I want that's my answer. This is my answer. This is another form of the answer. I need the form that looks like that. So I'm going to add the 5x over and move the 2 over. And now my equation is in standard form. Now, the cool thing is, I didn't need a new process, I didn't need a new procedure. I point sloped it and then rearranged things to get what I wanted. Can we do the same thing for slope intercept? Yes, you do whatever you want, but you don't need a new strategy. Find the slope. That one didn't work out so well. Did I make a mistake? No, I got 3/5 for my slope. So y plus 2 equals 3/5 x plus 2. I am using this point. You can use whichever one you want. It won't impact your answer. Remember, both points are on the line, so you're just picking one to use. So y plus 2 equals 3/5 x plus 6/5. This was my point slope form right here. Now, if I want to end up with slope intercept, then don't I need this by itself? So I'll subtract the 2 over. So 3/5 x, let's see, that's 10/5, minus 4/5. Is that okay? So, do whatever you want, but I'm going to do all of those problems exactly the same way. I'm going to point slope all of them, and then if I'm doing point slope, I stop. If I'm doing standard form, I do this messing around. If I'm doing slope intercept, I just get y by itself. Write the equation of a line. All right, number 7. Write the equation, write an equation for the line containing this point in parallel parallel to this line, all right? What are you thinking?
Point slope, we use 4 as the slope.
Yeah, absolutely. If they're parallel, isn't this gonna be my slope? So y plus 2, this is my only point, I don't get to pick this time, but I only need one, I have one. Y plus 2 equals 4, x minus 3. Is that okay? It says write an equation. Is that an equation? It's the point slope form. If you don't like it, then mess around with it and change it into some other form if you wish, but it's perfectly okay as it is. Write an equation for the line containing, oh, same thing, only this time we're doing perpendicular.
1/4.
So we're gonna write exactly the same thing, but instead of using 4, we will use negative 1/4. All right. Now it looks like things are getting a little bit more interesting. Given these points, I think I'm gonna plot them so I have some sense of what's happening. So A is 0 is 0. B is 2, 5. C is AB, okay, no work with that one. And D is 4, 0. And we're talking about quadrilateral ABCD. Now you remember, let's see, this is, you remember from geometry that when we say ABCD, they have to be connected in that order, okay? So you can't be mixing the letters around. ABCD means they're connected in that order. So I'm going from A to B, and then I'm going to C and back to D again. So does it make sense to you that it would be over here somewhere like this? That this would be point C? All right, so. Thoughts on that? Alex?
Find the slope between A and D.
A and B?
A and D.
A and D, okay.
And then you would use the slope to do some kind of B.
Absolutely. And actually, it's even easier than that because A and B happen to be horizontal. So to get from A to D, we just basically counted over 4. These two are also, since it's a parallelogram, these two are also going to be straight across from each other horizontally. And I'm going to count over 4. So if I start at this point and count over 4, what are these coordinates?
6, 5.
6, 5. If, Alex, this point had been like up here, then I would have used the idea of slope, because then I would have had to count over and up, and then I would have had to count over and up the same amount from that point. But this one was easier because we just went straight across. All right, write the equation of the line tangent to this circle. Okay, this is a circle, centered at the origin with a radius of 5. So use your imagination as a circle. And I want to write the equation of the line tangent to this circle at the point negative 3, 4. So here is the point negative 3, 4. And here is the tangent line. And I need to write the equation of that line. So think about all the problems that we just did. What did we need to write that equation? What information did we need? slope and a point, right? Had to have a slope and a point. I have my point, so now I need to worry about the slope. Any thought on that, geometry students?
Could it be some with like the angles or like, I don't know,
Oh, yeah.
the fact that it's gonna be 180 degrees? I forget what like the terms are from geometry, but
Yeah, you're right, you're getting there. And so, you're getting there. Were you gonna say something?
Wait, no, I thought I had it, but I don't.
Alex?
Find slope, the origin for 3/4 since it's centered around the origin, and since it's tangent, it's 90 degrees.
Exactly. A tangent and a radius are perpendicular at the point of tangency. So I can find the slope of my radius. Remember, this is the origin. So the slope of my radius would be 4 over -3. Would you agree with that? Which means the slope of my tangent line, which is perpendicular, will be 3/4. So y minus 4, there's my point, equals 3/4 x plus 3.
How's the slope 3/4?
This is a radius, right? That's a radius of the circle. I can find that slope because I have this point and this point, so I just find the slope. There's a theorem in geometry that says a radius and a tangent are perpendicular at the point of tangency. That's just fact. So that's perpendicular, negative, reciprocal. Okay? That was fun. You said 10-10 is when we end? Alright. I think we'll stop there and then we'll pick up here next time. So get your things gathered up. You're gonna leave everything here.